Okay, so similar polygons is when you have two or more shapes and they are stretched or shrunk by a scale factor. So the scale factor is how the corresponding sides change. And it's by a constant scale factor. So you don't want one side to change because you multiply by 2 and the other side changes because you multiply by 3. Okay, so your scale factor has to be the same as you're going through all of your corresponding sides. So to find it, you divide one corresponding side by the other. Okay? So, in order for two polygons to be similar, again, we're not looking at congruence like we did last unit, we're looking at similarity. So in order for them to be similar, first they have to be the same shape. So you can't have a rectangle and a circle and them be similar. Okay, so the shapes have to be the same. And then their angles must be congruent. And their sides must be proportional. So their angles are congruent and sides are proportional. And again, this is the corresponding angles and the corresponding sides, just like last unit. So we want to match them, and then we want to make sure that all of the sides are proportional. So the first one we want to know, are the rectangles similar? And if so, we want to find the scale factor. So it doesn't tell me which one is the original, but we'll say that A, B, C, D is our original. So first I need to check if my angles, my corresponding angles are congruent. So A matches W, B matches X, D matches Z, and C matches Y. Are all of those angles going to be congruent? Yes, why? And the rectangles have what kind of angles? Right angles. So if they're all right angles, they're all equal to 90. Good. So we're good on the angles. So now we just need to know if the sides are proportional. So we need to say, is 18, so 18 is AB. Which side matches AB on this guy over here? WX. So we need to know, is 18 divided by 25 the same as 36 divided by 45? Okay, so we just matched. So we said 18 over 25, 36 over 45. We're going to see if they're the same. So to see if they're the same, we can just divide. So is 18 divided by 25, so 0.72. Is that the same as 36 divided by 45? No. So these are not equal, so they're not similar. Good. Any questions on why it's no? Alright, let's look at number 2. So number 2, first we check our angles. So T matches G, N matches R, good, and P matches K, good. So we have our corresponding congruent angles. This is 30, 60, 90. So now we just have to match our sides. So I'm going to start here with this 16. Which side does the 16 match on this one over here? 8, good. So 16 over 8. We want to know, does that equal, let's go 30 over 15. And does that equal 34 over 17? So let's try it out. So 16 divided by 8, 2, good. 30 divided by 15 is 2, and 34 divided by 17 is also 2. So are they similar? Yes. Yep. So then to find the scale factor, it doesn't tell us which way it's going, so which one is the original. So we can say the scale factor, first we spell it right, scale factor is 2 if we're going from the smaller one to the bigger one. But if I'm going to the bigger one to the smaller one, what would be my scale factor? 1/2. Good. So if it doesn't tell you which one is the original, you just put them both. So if you go big to small, your scale factor is going to be like a fraction. If you're going small to big, it could still be a fraction, but it'll be like a bigger number. All right, let's look at 3. So on 3, I don't know any of the angle measures, but I know by my little tick marks that A matches D, good, B matches, and C matches F. So we have our corresponding angles, so now we just check our sides. So again, we start with 10. Which side does it match? 20. Then we can say 6, and it matches, and then, good. So then we check them and we see if they're the same. Are they? Yes. What do they all equal? Good. So this is a yes. And so our scale factors are either 1/2 if we're going big to small, or 2 if we're going small to big. Okay. So if I multiplied all of my little ones by 2, 10 times 2 gives me 20, 6 times 2 gives me 12, 7 times 2 gives me 14. Okay. If we were going the other way, 20 times 1/2 gives me 10, 12 times 1/2 gives me 6, and 14 times 1/2 gives me 7. Okay. So again, it doesn't tell me which one is the original, so we'll just find them both. So how about number 4? Are those similar? So I know that my sides are proportional. Do I know my angles are congruent? So we cannot assume similarity, because we do not know if corresponding angles are congruent. Now, are they? Probably, yeah. But since it doesn't tell us, we don't want to assume. Okay, and the other thing that we're doing today is we're finding missing sides. So in number 5, it says, given that the quadrilaterals are similar. So it's telling me that they're similar. We want to find x. So in order to do this, we want to set up a little proportion equation like what we did for the warm-up. So in this one, you want to find a proportion that you know. And then you set it equal to what you're trying to find. So in this first quadrilateral, I've got x plus 2 over here. That's what I'm trying to find. But I know the 35. So the 35 is what I'm going to start with. And then which side does the 35 match in the other quadrilateral? 25. Good. Okay, so set up a proportion that you know. And As long as it like matches up, no. Yeah. So I'll talk more about that after we set it up. So then we have x plus 2. Which side does it match? Good.
Does it matter if it goes on top or bottom?
No. Well, yes. So you can set up these proportions like 8 different ways, okay? But you have to make sure that you are matching. So like since I started with the 35 on the top, I have to have the x plus 2 on the top, okay? But I could have said the 25 was on the top and then the 15 would have to be on the top. So whichever quadrilateral you start with in your numerator, you want that to be the numerator in the other equation as well. Okay. Well, we don't know that we don't know that our scale factor is 2. So now we cross multiply. Yep. So then 35 times 15 is 525 equals 25 times x plus 2. Okay. Then you can distribute. So we get 525 equals 25x plus 50. And now it's just a regular old equation, so you can subtract. And then you can divide. And so we get 19. Questions? Alright, one more. Let's look at 6. So 6 we want to find x and we want to find y. So again, we'll start with a proportion that we know. So I know this side JK is 54. Which side does it match in the other one? 42. So then we can find the x first if we want to. Which side does the x match? Yeah, I would say the 28. Because if you look, the x is a little bit smaller than the y, and 28 is smaller than 35. Then we just cross multiply. We'll do that one next. You don't want to do them all at the same time. Okay. So we do 54 times 28, which gives us 1512, equals 42x. And then what would be my last step? You got it. Divide by 42. Good. So x equals 36. Now, when we're solving for y, we can still use the 54 and the 42, or we can use the 36 and the 28. It don't matter. Either way, we'll get the same answer. We'll use the 54 and the 42 since we already set that one up. And then that would equal y over 35. So then we cross multiply. So 54 times 35 is 1890 equals 42y. And then my last step, we divide and we get what? Good. Questions? Yeah. Okay, good. I was about to say, I have no clue. Sorry. Okay. So, the other way which makes more sense to some people is to use the scale factor. I'm just more algebra minded, so I like to set up the proportion and to solve for x. But the other way that you can do it is you can use the scale factor and then multiply. So like in this one, if we did 54 divided by 42, and we made it a fraction, we would get that the scale factor is 9/7. So if I multiply 9/7 by 42, I get 54. Well then, if I'm looking for x and y, I can do the same with the 28. So I can do 9/7 times 28, and that gives me 36. Well, that was our x. And then if I do 9/7 times 35, I get 45, which was our y. You can also do it that way if you want to, if that makes more sense to you. So you find the scale factor and then you just multiply. Again, I would rather solve for x just because, like in problems like number 5, you're looking for x, you're not necessarily looking for the side length. So like in this one, if we did 35 divided by 25, we get 1.4. So 25 times 1.4, there's my 35. Well, if I'm looking for x, I've got that 15 times 1.4 gives me 21, which 21 is the side length, but since we want x, we would have to do 21 minus 2 to get our x of 19. Okay, so that's why I like to always set it up in a proportion. But again, if the scale factor makes more sense to you, you can solve it that way as well and you get the same answer. So either way. Questions on this though?